All right, starting on problem number 4. So problem number 4 says a recipe for 12 apple cinnamon muffins calls for 1 cup of flour. The number of muffins that can be made varies directly with the amount of flour. There are 2 and 3/4 cups available of flour. How many muffins can be made? Now, again, there's several ways to do this. I'm going to take the basic approach, which is come up with the equation and then substitute the value in. This is, again, a two-part question, or rather, 2 parts to solve the question that they're asking. So, first of all, we're given a very important information. It says 12 apple cinnamon muffins calls for 1 cup of flour. All right, so we can write that down as important information, or you can highlight it or underline it. Just keep it in mind. The next part says the number of muffins varies directly with the amount of flour. So that should be really important because that's already giving us an equation. All right, so I want to write down stuff that I know. It says 12 muffins calls for 1 cup of flour, and we're also given that it varies directly, right? So varying directly means that we can have an equation to denote this situation. So this is what we're given so far. 12 muffins corresponds to 1 cup of flour, and we're given a direct variation, right? So it says varies directly. Looking at this equation, it says the muffins varies directly with the amount of flour. So if you wanted to sit here and change your variables, you can actually do this. It says muffins varies directly with flour. So you can do this equation. Muffins varies directly with flour. So remember, K is a constant of variation, which is that coefficient that tells the relationship between the two. So it says find the amount of muffins we can make given 2 and 3/4 cups of flour. Well, before I can do that, I first need to figure out my equation or the value of K. So again, if you remember, to find the value of K, we first need to solve for K here. We're multiplying by F, so I'm going to divide by F on both sides. Divide by F, divide by F. Again, it is the same as the previous example, right? We need to find the value of K divided by X on both sides. The constant of variation is the ratio of the output over the input. So in this case, the constant of variation is the muffins divided by the quantity of the flour. So again, I'm going to get my constant of variation. It is muffins, 12 to the cups of flour, 1. So the value of K is 12. Now that we have that, our equation is y equals 12x. Or you want to use these variables, the ones that you came up with, we have the number of muffins is equal to 12 times the number of cups of flour. Now it said, how many muffins can we make if we have 2 and 3/4 cups of flour? Well, that's our input. This is our flour quantity, right? What do? We insert it into this equation. So the amount of muffins I can make is 12 times the quantity of flour, which is 2 and 3/4. Now be very careful. Make sure you're using a calculator for this. Again, I hope you understand that 2 and 3/4 should be first converted into a decimal or a fraction in your calculator. So I'll use the calculator here. So again, it's 2 and 3/4. So I'm going to first make that into an improper fraction or a decimal, which is 11/4. Now I can actually enter my equation. It's 12 times, I'm going to enter the fraction that I just got here, 11/4. Again, you can turn this into a decimal, 12.2.75. That'll work just fine as well. Now we'll do it here, right? Suppose that you got 275, 2.75. There it is. As you can see, I get the same answer for both. This is just in decimal form. This is in ratio. There it is. So if I have 2 3/4 cups, here it is in fraction, here it is in decimal, I can make 33 muffins. So going back to the problem, 33. All right. Problem number 5. Whichever way the equation represents a direct variation. If it does, find the constant of variation. All right, so we're given a very special equation here. 6y equals 5x plus 1. 6y equals 5x plus 1. That is the equation I am given. All right, so when looking at this, again, we have to understand what a direct variation equation is or what it looks like. A standard direct variation equation is an example or a something that follows this form: y equals kx. Now again, notice that looks very distinct. There's something very special about it. We have our constant of variation k, and we have our input being multiplied to it to get my output. Input times the constant of variation equals our output. When we look at this, the first thing we want to do is try to get it to y equals. Because as you can see, our direct variation must be y equals. Well, here, if you look at the equation, we're multiplying 6 times y. So to get rid of that multiplication by 6, I'm going to divide by 6. Divide by 6. So I get y equals 5x plus 1 over 6. Now again, let's not forget, we can separate this fraction because we have different denominators or denominator parts as part of one, multiple numerator parts as or over one denominator. So I can actually write this as y equals 5/6 x plus 1/6. Now look at the discrepancy here. Okay. A direct variation has x being multiplied by a constant of variation, k. Notice how there's no sum or difference. There's nothing else being added to it. When you look at this equation, y equals kx, notice how there's an additional piece that is being added. Because I'm adding something to this product, this is not a direct variation. Again, a direct variation is anything of the form y equals kx where we are multiplying the direct or the constant of variation times the input. Again, here we're adding 1/6. That is not correct. We have to have this example, y equals kx, right? So y equals kx, input multiplied by constant variation, we get our output. In this case, we are adding the 1/6. So this is not a direct variation. So no, this does not represent a direct variation. Why? Because we are adding a constant. So we have, okay. Next, we're going to go to problem number 6. Suppose y varies directly with x. So again, they're telling me that it is a direct variation. We can assume. By us seeing this, I know I can write it in the form y equals kx. That says write an equation. And then secondly, find the value of y when x is 12. So we have a multi-part question here again. So I'm going to start off by writing my most important parts, which is y equals 7 when x equals 6. Okay. So looking at this, y equals 7 when x equals 6. And again, they want me to find the equation y equals kx. Now, if you remember, we have a shortcut for this to find the value of k because they're telling me I can use this direct variation, the equation. I can find the value of k fairly easy, right? K is the ratio of the output over the input. So to find the value of k, I just divide y over x. Y is 7, x is 6. There's my constant of variation. So my equation, I just plug in what I know. Again, x and y are input and outputs. Yes, they gave me x is 6, y is 7 here, but they gave it to me so that I can find the value of k, which is my constant of variation. But the equation You guys remember what an equation stands for? What it is, it's a relationship where we pair up an input to an output, right? So here, x is my input, y is my output. So the only value I can fill in would be k. So in this case, my equation is 7/6 x. Now we'll do both parts here. That said, also find y when x equals 12. Well, look, they're telling me x is equal to 12. Notice how, again, this is the equation that made up this connection here, input to output. So now, because I found the equation, I just plug in my new x. So y equals 7/6 x. They said x is 12. Y equals 7/6 times 12. You can reduce here. Use your calculator. I'm going to reduce here. I get 2 over 1. So I get that y equals 14. Again, I'm pretty sure some of you guys are probably looking for shortcuts, and some of you guys will find those shortcuts, but I will not talk about those here. I'm going to stick strictly to the example and the notes. There it is. So my equation was 7/6 x. So it's 7/6 x. That is my constant of variation equation. And when x is 12, I plugged it into the equation and I got 14. There it is. All right. Let's go to problem number 7. All right, problem number 7 says, suppose y varies directly with x. They want you to find the equation, write in the equation a direct variation, and they want you to graph the equation. All right, so here we'll first find out the equation. So again, notice I'm given the fact y varies directly with x, and I'm given the points. Y is 8 when x is 1.6. So I'm going to first write down my points. Y equals 8 when x equals 1.6. And they want me to first write the equation and graph it. So looking at this, first thing I'm going to do is find the equation. So again, they're telling me the fact, hey, this is a direct variation. Anytime they say that it is a direct variation, we can think of this formula. More importantly, something even easier. The constant of variation, k, is always y over x. It's the output divided by the input. So look, k is y over x. Y is 8. X is 1.6. You handy dandy calculator. 8 divided by 1.6 is 1 over 0.2. On the problem, it says it wants it in simplified. I'm probably going to go with a fraction. So let's use our calculator, right? It is 8 divided by 1.6, 5. So my equation is k was 5. So y equals 5x. That is the equation. My constant of variation is 5. My input is x. My output is y. So I do not input anything for those, right? I don't substitute. X and y are my variables. The only one I can find is k. So when I go here, I'm going to tell my equation, 5x. Now it says to graph, right? Now again, this is really easy. You can actually graph this in your calculator, right? Y equals 5x. Let me make sure I have. Oh. All right, so to graph this, again, you can use your handy dandy calculator. Go to the function and graph it. We know that my first coordinate point is 0, 0. And my second coordinate point is 1, 5. Why? Because I used some points. Save it, check it, and we're good.